Dawn broke cold and gray over a remote Luftwaffe airfield in occupied France during the late summer of 1943. The fog clung to the runway like a shroud, obscuring the silhouettes of scattered Messerschmitts and Focke-Wulfs awaiting their morning maintenance. Somewhere in the distance, the muffled thump of anti-aircraft batteries echoed across the countryside, a reminder that the war was never truly silent. Oberleutnant Werner Schultz, chief technical officer for Jagdgeschwader 26, received the dispatch at his quarters shortly after 4 in the morning. The message was brief but electrifying. An American P-47 Thunderbolt had been forced down behind German lines. The pilot was in custody. More significantly, the aircraft itself had survived the landing largely undamaged. For German intelligence, this represented a windfall of staggering proportions. Throughout 1943, Luftwaffe pilots had filed increasingly alarming reports about the massive American fighter that was appearing in greater numbers over occupied Europe. The aircraft seemed to defy the laws of aerodynamics, impossibly heavy, yet fast and powerful at high altitude. German command needed answers, and now they would have them. Schultz dressed quickly and made his way through the morning mist toward the hangar where the captured fighter had been towed. He was not a combat pilot. His expertise lay in aeronautical engineering, having spent the pre-war years working in design offices for Messerschmitt. His assignment was to dissect enemy aircraft, identify their vulnerabilities, and provide tactical recommendations to operational units. It was methodical work that suited his temperament. He trusted mathematics and metallurgy far more than propaganda or political doctrine. When he finally laid eyes on the P-47 sitting beneath the harsh lights of the maintenance hangar, his first impression mirrored that of every German pilot who had encountered the type. The aircraft was grotesque. It appeared bloated, impossibly wide through the fuselage, with a blunt nose that seemed to challenge every principle of streamlined design. German pilots had taken to calling it the Jug, short for Juggernaut, though some preferred the less flattering flying milk bottle. The aircraft weighed nearly 8 tons when fully loaded. By comparison, the Focke-Wulf FW-190, Germany's premier frontline fighter, tipped the scales at roughly 4 tons. Looking at the P-47 from the side, Schultz could understand the skepticism. It looked like something that should never leave the ground. But Schultz had learned long ago that appearances could be deceiving. He approached the aircraft with his clipboard, his team of mechanics and junior engineers gathering around him. Whatever his initial aesthetic judgment, he knew that this machine had been outflying and outfighting the German interceptors for months. There was a reason for that, and he intended to discover it. The heart of the machine. Schultz began where any engineer would, with the power plant. The cowling panels had already been removed by the ground crew, exposing the massive radial engine that gave the P-47 its distinctive appearance. For a long moment, Schultz and his team simply stared. The Pratt & Whitney R-2800 Double Wasp was an engineering marvel. 18 cylinders arranged in 2 radial rows, each machined with a precision that German factories were finding increasingly difficult to maintain. Schultz ran his hand along the crankshaft housing, noting the quality of the castings, the uniformity of the cylinder heads, the sophistication of the cooling fins. Every component spoke of an industrial system operating without the constraints that plagued German production. There were no substitute materials here, no simplifications forced by resource shortages. This engine had been built the correct way, not the expedient way. Schultz began his calculations. Based on displacement, compression ratios, and the integrated turbo supercharger system, he could already see snaking through the fuselage. This engine was producing at least 2,000 horsepower, possibly more under combat conditions. The BMW 801 radial that powered the FW-190, by contrast, generated approximately 1,700 horsepower at maximum output. And that figure represented the absolute limit of German engine metallurgy and manufacturing tolerance. The Americans were mass-producing engines with 20 to 30% more power, and they were doing so with apparent ease. One of Schultz's mechanics, a veteran who had serviced German fighters since the invasion of Poland, pointed out a feature that made the engineer pause. Each cylinder was individually removable. If combat damage destroyed one cylinder, a maintenance crew could replace just that component without tearing down the entire power plant. German engines required extensive disassembly for similar repairs. This American design assumed not only that damage would occur, but that rapid field maintenance was a priority. It was a philosophy of abundance, assuming that parts would be available, that mechanics would be trained, that logistics would function smoothly. It was the philosophy of a nation that expected to win a long war. The supercharger secret, but the raw power of the R-2800 was only part of the story. What truly distinguished the P-47 was the system that allowed it to dominate at altitudes where German fighters struggled: the turbo supercharger installation. Schultz had read intelligence briefs about this system, but confronting the reality of its implementation was sobering. A complex network of armored, ducting-channeled, superheated exhaust gases from the engine, running them back through the fuselage to a turbine mounted in the rear section of the aircraft. This turbine spun at speeds exceeding 20,000 revolutions per minute, driving a compressor that forced pressurized air back into the engine's intake. The engineering challenges were formidable. The exhaust ducting had to withstand temperatures that would melt inferior alloys. The turbine bearings had to survive rotational speeds that would destroy standard components. The entire system required precise calibration. Too much boost would destroy the engine. Too little would negate the performance advantage. German engineers had experimented with turbo supercharger technology, but the results had been disappointing. The technical hurdles were too steep, the materials too exotic, the manufacturing tolerances too demanding. Several prototype installations had been attempted, but none had reached operational status. The systems were temperamental, prone to failure, and required maintenance expertise that was in short supply. Yet here, in a production aircraft that was being manufactured by the hundreds each month, was a fully functional turbo supercharger system that worked reliably enough for combat operations. Schultz performed the altitude calculations. With this installation, the P-47 could maintain full engine power at 25,000 feet and above, altitudes where the mechanically supercharged BMW and Daimler-Benz engines in German fighters were gasping for air. Above 7,000 meters, the FW-190 and BF-109 experienced significant power loss as their superchargers struggled against the thinning atmosphere. The P-47 would be accelerating, its massive engine drinking pressurized air and converting it into speed and climb rate. One of his junior engineers asked the obvious question: could this system be replicated for German use? Schultz shook his head slowly. The turbo supercharger required precision machining that was beyond Germany's current manufacturing capacity. High-grade steel alloys were in desperately short supply. The skilled labor needed to assemble and calibrate such systems was being drained away by the Eastern Front. German industry was already straining to produce sufficient numbers of basic fighters. Adding this level of complexity was impossible. The realization settled over the team like a weight. The Americans had not simply built a superior aircraft. They had built an aircraft that represented an entirely different tier of industrial capability, one that Germany could not access: the airframe revelation. Moving beyond the propulsion system, Schultz turned his attention to the airframe itself. The captured P-47 bore the scars of combat. Cannon strikes had punctured the fuselage, machine gun rounds had torn through control surfaces, and hydraulic fluid stained the interior surfaces. Yet the aircraft had flown home and executed a controlled landing. Schultz examined the structural damage with growing unease. Multiple 20mm cannon hits, the kind of damage that would typically send a German fighter spinning toward the earth in pieces. But the P-47 had absorbed the punishment. The heavy-gauge aluminum skin, the robust internal framing, the redundant control linkages, all contributed to extraordinary durability. He pulled damage reports from Luftwaffe combat units and cross-referenced them with the physical evidence before him. The pattern was consistent. German pilots repeatedly described pouring cannon fire into P-47s, watching their rounds connect, and then watching in disbelief as the American fighters simply kept flying. Some limped home, trailing smoke. Others executed evasive maneuvers and returned fire. The reason was evident in the construction, where German designs optimized for weight savings and agility, accepting reduced structural margins as the price of performance. The P-47 was engineered like a flying tank. The cockpit featured extensive armor plating, protecting the pilot from multiple angles. The windscreen was armored glass, considerably thicker than anything installed in German fighters. Most significantly, the massive R-2800 radial engine served as an inadvertent shield. Unlike the liquid-cooled inline engines in the Bf-109 and Fw-190, the radial configuration had no vulnerable coolant system. A German fighter that took damage to its cooling system would overheat and fail within minutes. The P-47's radial could lose multiple cylinders and continue operating. Documentation recovered from the aircraft's maintenance logs showed missions where P-47s had returned to base with catastrophic damage. Cylinders destroyed, fuel tanks punctured, control surfaces shot away, yet still flying. One of Schultz's team made an observation. The design was over-engineered, with weight devoted to durability that could have been allocated to enhance performance. Schultz agreed, but noted the critical difference. The Americans possessed engines powerful enough to carry the additional weight. German designs lacked that luxury. German aircraft operated at the edge of what was technically achievable, extracting maximum performance from limited resources. American designs incorporated massive safety margins, compensating for any inefficiency through brute mechanical force. And brutally, the American approach was proving more effective in combat. The wall of lead. Schultz next cataloged the P-47's offensive armament. 8 Browning M250 caliber machine guns were mounted in each wing. The implications were devastating. Each weapon carried approximately 400 rounds of ammunition. Total ammunition capacity, 3,200 rounds. Combined rate of fire, over 100 rounds per second. A typical 2-second firing pass, standard for aerial combat, would launch 200 heavy projectiles toward the target. By comparison, German fighters typically mounted 2 or 4 machine guns supplemented by 1 or 2 cannon. A Bf-109 might carry 60 rounds for its cannon and 500 for its machine guns. Once expended, the pilot had no choice but to disengage and return to base. The P-47 pilot could sustain fire for over 30 seconds of continuous shooting. In practice, enough for multiple extended bursts across several separate engagements. Schultz examined the .50 caliber ammunition itself. These were heavy, high-velocity rounds capable of penetrating armor and structural components that would deflect smaller projectiles. German pilots had described P-47 fire as a wall of lead, and now Schultz understood the description's accuracy. With 8 guns converging at a focal point, anything caught in that cone of fire would be torn apart. German aircraft, with their lightweight construction and minimal armor, would disintegrate under such concentrated firepower. The tactical implication was clear. The P-47 did not need surgical precision. It merely needed to get an enemy aircraft generally in front of it and pull the trigger. The sheer volume of fire would do the rest. Schultz made a note in his report. Recommendation to avoid head-on engagements with P-47 at all costs. Probability of surviving return fire assessed as minimal. The industrial abyss. As Schultz compiled his technical findings, a broader pattern emerged that transcended any individual component. Every system on the P-47 pointed toward an underlying industrial capacity that defied comprehension. The R-2800 engine demanded precision machining and exotic alloys. The turbo supercharger required advanced metallurgical processes. The airframe consumed massive quantities of aluminum. The armament presupposed a functioning ammunition industry capable of producing millions of .50 caliber rounds. Any single one of these elements would strain German manufacturing. The P-47 integrated all of them into a single operational aircraft and was being produced in quantity. Schultz requested production intelligence from higher command. The figures that came back were crushing. Republic Aviation was manufacturing P-47s at a rate exceeding 500 aircraft per month by late 1943. Plans called for increasing production to 6, 7, even 800 per month throughout 1944. German factories, by contrast, struggled to produce 3 to 400 single-engine fighters monthly across all types combined. And German production was subject to constant disruption from Allied bombing raids that were growing more effective with each passing month. But the disparity went deeper. The R-2800 engine was not exclusive to the P-47. It powered multiple American aircraft types. Total projected production of R-2800 engines would exceed 125,000 units by war's end. 125,000 engines, each producing 2,000 horsepower. Germany's total aircraft engine production for all types throughout the entire war would approximate 250,000 units, most of them significantly less powerful than the American Radial. The Americans were building more of a single advanced engine model than Germany could produce engines of all types combined. Schultz sat alone in his office, rechecking his calculations, convinced he must have made an error. But the numbers remained unchanged. American aircraft production for 1943 was projected to exceed 85,000 aircraft. German production would reach approximately 25,000, a ratio of more than 3 to 1. Yet even this understated the disparity, because American aircraft were on average heavier and more complex. A single B-17 bomber required more aluminum and labor than 3 Bf-109 fighters. The Americans were building thousands of B-17s while simultaneously producing fighters, transports, and naval aircraft. And America was fighting a global war, supplying the Soviet Union with thousands of aircraft and vehicles, equipping British forces, maintaining operations in the Pacific, and still outproducing Germany in every category. A dangerous truth. Schultz's final report was due for submission to higher command in Berlin. As he drafted the document, he understood he was composing something potentially career-ending, possibly dangerous. The report documented the P-47's technical superiority across multiple domains. It acknowledged frankly that Germany lacked the industrial infrastructure to produce equivalent systems. And it contained a conclusion that would certainly be interpreted as defeatist. The P-47 Thunderbolt represents an industrial and technological sophistication exceeding Germany's current capabilities. Its widespread operational deployment indicates American production capacity far surpasses previous intelligence estimates. Tactical recommendation: minimize high-altitude engagements with P-47. Strategic assessment: continued attrition warfare against numerically and technically superior enemy forces will produce unsustainable losses. In bureaucratic language, Schultz was stating the unthinkable. Germany could not win this fight. Continuing on the current trajectory would lead to inevitable destruction. His commanding officer read the report with a mixture of professional respect and personal concern. The findings were accurate. He acknowledged, but would not be well received in Berlin. Leadership preferred reassuring narratives to uncomfortable realities. Schultz forwarded the report up the chain of command. No official response ever came. Through informal channels, he later heard it had been dismissed as excessively pessimistic. One staff officer reportedly characterized Schultz as demoralized by enemy propaganda, claiming the P-47 represented crude American engineering inferior to German designs. Schultz was unsurprised. He had observed this pattern before. Intelligence contradicting Nazi ideology was rejected regardless of its accuracy. The prophecy fulfilled. In the months following his examination of the captured P-47, Schultz watched his predictions materialize with grim precision. P-47s appeared in ever-increasing numbers over European skies. German fighter losses mounted steadily. Experienced pilots were shot down and not replaced. The training pipeline could not keep pace with attrition. The tactical recommendations Schultz had made, avoiding high-altitude combat, employing hit-and-run tactics, were gradually adopted by field units, but the adjustments came too late. The Americans had achieved air superiority through overwhelming numbers and technical advantage. Schultz examined other captured American aircraft as they became available. Each told the same story: superior materials, sophisticated systems, evidence of an industrial base operating at a scale Germany could not approach. A captured C-47 transport proved to be one of over 10,000 that would ultimately be built. Germany's entire transport fleet numbered a few hundred aircraft, most of obsolescent design. A P-51 Mustang combined the range of the P-47 with even better performance. Powered by a Packard-built Rolls-Royce Merlin engine produced under license in American factories. Thousands of them. Every aircraft reinforced the same inescapable conclusion: Germany was losing an industrial war against an adversary with crushing material superiority. What haunted Schultz was not the ignorance, but the willful blindness. The intelligence existed. German agents were filing reports on American production. Captured equipment provided proof of quality. But the leadership refused to accept implications that contradicted ideological certainty. Or perhaps more accurately, they accepted the facts but believed that German determination and tactical superiority could overcome material disadvantage. Schultz had been trained as an engineer. He believed in numbers, in physics, in mathematical reality. And the mathematical reality was undeniable. Germany was being buried beneath an avalanche of American steel. The arithmetic of defeat. After the war, when production records were declassified, Schultz's estimates proved conservative. He had actually underestimated American capacity. Total American aircraft production from 1940 through 1945 exceeded 300,000 aircraft. German production over the same period approximated 94,000. The United States produced over 15,600 P-47 Thunderbolts alone, more than Germany produced Bf-109s and Fw-190s combined. The R-2800 engine that Schultz had examined with such foreboding in 1943 was manufactured in quantities exceeding 125,000 units, produced not only by Pratt & Whitney, but by Ford, Chevrolet, and other automotive manufacturers converted to wartime production. The industrial mobilization that generated these numbers was unprecedented in human history. Factories that had manufactured automobiles were retooled to produce aircraft engines. Shipyards that had built freighters were launching aircraft carriers. And critically, the quality remained consistently high. Late-war American aircraft showed no evidence of declining standards, no material shortcuts, no compromises forced by resource depletion. German aircraft, by contrast, displayed increasing evidence of strain. Lower-grade materials, simplified construction, quality control issues as experienced workers were conscripted and replaced by forced labor. Interrogation and reflection. Schultz survived the war and found himself interrogated by American technical intelligence officers who had discovered his 1943 report in captured files. They were particularly interested in his conclusions. An American officer asked directly whether Schultz had truly concluded from examining a single aircraft that Germany would lose the war. Schultz considered the question carefully before responding. He had concluded that Germany could not win an industrial war against America. The P-47 had provided evidence of production capacity Germany could not match. Every component, every system demanded resources and manufacturing sophistication that exceeded Germany's total capabilities. The American noted that many German engineers must have reached similar conclusions. Schultz agreed. Many had understood the situation. But in the Third Reich, articulating inconvenient truths was dangerous. Silence was safer than accusations of defeatism. The interrogator observed that Schultz's report had been found in the files marked filed. No action required. Schultz laughed bitterly. He had expected nothing else. The Nazi leadership had not wanted intelligence. They had wanted validation of pre-existing beliefs. When reality contradicted ideology, reality was dismissed. The lesson unlearned. The story of Werner Schultz and the captured P-47 Thunderbolt serves as a microcosm of Germany's strategic collapse. A qualified engineer examined enemy equipment, reached accurate conclusions about Germany's industrial disadvantage, and was systematically ignored. His experience paralleled that of others. Admiral Canaris, who warned about American industrial capacity. Albert Speer, who understood Germany could not win a production war. Adolf Galland, who recognized the P-47's tactical superiority. Sepp Dietrich, who knew the Ardennes offensive would fail for lack of fuel. In every case, competent professionals identified the truth and found themselves trapped in a system where truth was subordinate to ideology. They provided accurate assessments and were dismissed as pessimists or defeatists. The Nazi regime was constructed on the premise that German racial and cultural superiority would overcome material disadvantage, that willpower and determination mattered more than industrial capacity, that ideology could defeat mathematics. They were catastrophically wrong, and men like Schultz knew they were wrong from the moment they examined the evidence. But knowing the truth and possessing the power to act on it are entirely different things. Schultz's report on the P-47 should have triggered a fundamental reassessment of Germany's strategic position. Instead, it was filed and forgotten. The P-47 went on to become one of history's most produced fighters. Over 15,600 were built. They destroyed thousands of German aircraft. They provided close air support for the invasion of Europe. They helped achieve the air superiority that made Germany's defeat inevitable. And it began with one engineer examining one captured aircraft in a foggy hangar in occupied France. Realizing that his nation had already lost a war they did not yet know they were fighting. Not a war of courage or tactics, but a war of factories and resources. A war where victory belonged to the side with more oil, more aluminum, more steel, and more industrial capacity. America possessed all these things in abundance. Germany had none of them. The tragedy was not that Germany lost. The tragedy was that the loss was mathematically inevitable, demonstrably predictable, and completely avoidable. Yet the system was incapable of acknowledging reality until reality arrived in the form of rubble and surrender. Werner Schultz understood this in August 1943. The rest of Germany would learn it in May 1945.